Welcome, everyone. Today's lecture is going to focus on what I believe is one of the most powerful, if not the most powerful, concept in all of finance: compound interest. Now, I know you're here to become effective managers and business leaders, and I promise you, understanding this concept is not just an academic exercise. It is absolutely fundamental to making sound financial decisions for any company.
So here's our roadmap for today. We're going to start with a practical business question you might face on day one of your job. Then we'll dive deep into the engine that drives financial growth. We'll decode the formula itself, piece by piece, so you understand the logic behind it. After that, we'll put the formula into action with some case studies. And finally, we'll cover the common pitfalls, the mistakes I see students make all the time, so you can avoid them.
All right, let's start with a scenario. Picture this. You're a manager, and your department has a $10,000 surplus for the quarter. Great job. Now you need to invest it for the next 3 years. You have two options on the table. Option A is a very straightforward 10% simple interest rate. Option B comes in a little lower, at 9.5%, but the bank tells you it's compounded. Now, at first glance, 10% looks better than 9.5%, right? The bigger number is always better. Or is it? This is exactly the kind of decision that separates a good manager from a great one.
To properly answer that question, we have to look under the hood. We need to understand the fundamental engine to financial growth, and that means getting crystal clear on the difference between simple and compound interest. They might sound similar, but in practice, they operate in completely different universes.
Before we even touch the math, let's use an analogy. The best way to think about compound interest is to imagine a small snowball at the very top of a long, snowy hill. As it starts rolling, it picks up a little more snow, right? But here's the key. The bigger the snowball gets, the more surface area it has, which means it picks up even more snow on its next rotation. Its growth isn't just steady, it's accelerating. That, in a nutshell, is the magic of compounding.
So let's break that down a bit more formally. With simple interest, your money grows in a straight line. It's linear. If you invest $1,000 at 10%, you earn $100 this year, $100 next year, and $100 the year after that. It's predictable, but it's constant. Compound interest, well, that's a different beast entirely. In the first year, you earn interest on your principal, but in the second year, you earn interest on your principal plus the interest you earned in the first year. Your interest starts earning its own interest. That's where the growth becomes exponential.
And this chart illustrates that divergence perfectly. Look at year one. The difference is tiny, almost negligible. You might even wonder what all the fuss is about. But fast forward to year 5, and you see a noticeable gap opening up. Now look at year 10. It's not even close. The compound interest line is rocketing upwards. This visual right here is the single most important reason why you should start investing early. Time is the fuel for the compounding engine.
Okay, now that we have the core concept down, let's get into the manager's toolkit. We need to be able to precisely calculate this growth, and for that, we have a formula. Now, don't be intimidated by the letters in the brackets. Think of each variable as a lever in your business strategy. Here it is. This is the compound interest formula. A equals P times the quantity of 1 plus I over N, all raised to the power of N times T. It might look like just a string of symbols, but once you understand what each part represents, you'll see it's actually a very logical and powerful tool. So let's deconstruct it. First up, we have P. This stands for principal. It's simply your starting money, the initial investment, the seed capital. In our business scenario, the principal was that $10,000 surplus. It's the foundation upon which all future growth is built. Pretty straightforward. Next is I, which is the annual interest rate. This is the number you'll usually see advertised, expressed as a percentage. It's your raw yearly rate of return. In our example, it was 10% or 9.5%. But as we're about to see, this raw number isn't the whole story. Now we come to a really crucial variable, N. This represents the number of compounding periods per year. This is the accelerator. How often is the interest calculated and folded back into your principal? If it's done annually, N is 1. If it's quarterly, N is 4. If it's monthly, N is 12. The higher N is, the more frequently your snowball gets a fresh layer of snow, and the more powerfully the growth accelerates. And finally, we have T for time in years. This is your investment horizon. As we saw in that bar chart, time is perhaps the most powerful variable of all. It works in partnership with N. The total number of times your money will compound is N multiplied by T. That exponent is the real engine of this formula. You know, this is why that quote, often attributed to Albert Einstein, rings so true. The most powerful force in the universe is compound interest.
It's the beautiful mathematical interaction between these variables, especially that exponential effect of time that creates such extraordinary results.
All right, enough theory. Let's move on and see how this formula actually works in practice. We're going to apply it to 2 distinct business case studies so you can see how you'd use this tool in a real-world setting.
So here are the inputs for our 2 cases. In case 1, we're investing a smaller principal, $1,000, at a higher rate of 6%, compounded quarterly for 3 years. In case 2, we have a much larger principal, $5,000, at a lower rate of 5%, but with more frequent monthly compounding over a shorter 2-year period. Notice how all the variables we just defined are laid out here.
Let's plug in the numbers for case 1. Our amount A will be our principal, $1,000, multiplied by, now inside the parentheses, we have 1 plus our annual rate, 0.06, divided by the number of periods, 4. And all of that is raised to the power of our periods, 4, times the number of years, 3. We have to do this to match our rate and time to the compounding period. And when we run the calculation, the final amount after 3 years is $1,195.62. That's a total of almost $200 in interest earned, thanks to 12 total compounding periods over those 3 years. Not bad at all for a $1,000 investment.
Now for case 2. We're following the exact same logical steps, just with different numbers. Our principal P is $5,000. Our rate I is 0.05 divided by our more frequent N of 12 for monthly compounding. And that's all raised to the power of 12 periods times 2 years. Here, the investment grows to $5,522.46. So even with a lower interest rate and a shorter investment horizon, the combination of a much larger principal and that high-frequency monthly compounding resulted in over $522 of growth after 24 compounding periods. This really shows how the variables interact.
Okay, applying this formula correctly is absolutely critical. So let's talk about the most common mistakes I see students make. Understanding the concept is one thing, achieving calculation mastery is another. Let's make sure you get this right every single time. I want you to burn these 3 rules into your memory. First, always match the period. You cannot use an annual rate with a monthly period. You must divide the annual rate I by N to find the correct rate per period. Second, calculate the total number of periods. Your exponent isn't just t, it's n times t. This tells you how many times in total your investment will compound. And third, and this is crucial, follow the order of operations. You solve what's in the parentheses first, then you calculate the exponent, and only then do you multiply by the principal. Follow these 3 rules, and your calculations will always be accurate.
I'll leave you with a final thought to ponder. We've spent this entire lecture discussing how compounding can be this incredible engine for building wealth for your company. But this engine is impartial. It's a double-edged sword. Think about corporate credit card debt, often with high annual interest rates that compound monthly or even daily. That same powerful, accelerating force can work against you, causing debt to spiral out of control. Understanding this principle isn't just academic. It's essential for financial survival and success in the business world.